So let's get started. Chris is ready to roll. I like to see it. Welcome in this morning to another Charger training, Friday training. This morning we have Bill Hall and Stephanie Layfield, and they're going to discuss the commercial reverse osmosis systems, design, operation, and practical applications. And as always, we have a bunch of our Charger guys online. So please, at the end of this or whenever you have a question, jump in and we'll get everything answered. Thanks for taking your time out this morning. And especially thanks for your business. We really appreciate it. So Stephanie, it's all yours.
All right. Thank you very much, Sue. So we're going to look into commercial RO, and I'm going to allow the Charger reps to talk specifics of different equipment and systems for y'all that are available. And I'm going to present more of the considerations and designs that you can use whenever you're looking at a commercial RO system. So value of a commercial RO, there's a lot of different applications for this type of technology. Be from whole home water purification, homeowners on a really bad well, which is my last choice on home water treatment, but sometimes it's unavoidable. Manufacturing, boiler feed, hospitals, car washes are a huge opportunity for them. I've even heard about a commercial RO being used on a horse farm to wash their horses with so that they had nice, clean horses to show. So there's a lot of different applications you can have. But this is going to be our high quality water, and it can meet really high quality standards while still meeting those larger flow rates. Comparing the difference in a point of use residential RO system versus a commercial RO system. Scope and scale is the biggest first thing. Home RO, you just need a couple gallons, storage tank underneath the sink, really simple, usually no electronics there. But whenever we go to a commercial, this is large scale, usually more than one membrane. Sometimes we can do it in one membrane. But we're looking at a lot higher flow rates and capacity here. Application, there's a wide variety of applications like we looked at for commercial versus home ROs. It's generally for drinking. Components for a point of use, there's no real electronics. It's all 100% off of physics, simple under the sink. But whenever we get up into our commercial, we're going to have monitors on it for flow and for TDS, creep, and pressure. And we have our booster pumps on it. We have a lot larger storage tank. We have to consider keeping that storage tank afterwards disinfected. And there's a lot more that goes into it. And then maintenance is very similar, just on a larger scale. Test your water. It's going to be our first thing and the biggest consideration whenever you're looking at a commercial RO. Test the water. Get a full water analysis. Always, always, always. This is your foundation. Especially with parameters like TDS, which is the first thing you measure with an RO. Hardness, we definitely need to know because that's going to foul up the membrane, and there's different pre-treatments that we can choose for that. Any organics, silica, which is like powdered glass, chlorine, iron, and then sediment. This will help you identify what potential issues could we have in the system, such as scale buildup or colloidals. That'll affect how we design our pre-treatment and sometimes even the post-treatment. It'll help us not get into a tight spot. The SDI test stands for Silt Density Index. This is something that you can do more on site than having to send it off. but this is going to evaluate the likelihood of the feed water causing fouling. So this is our suspended solids concentration. This is going to help you maintain the life of the RO. So you get a sample, and you're going to have a 0.45 or really tight micron filter. You measure the initial flow rate through that filter, and then allow it to go for an amount of time, 15 minutes or so, and then check the flow rate again. And we're seeing how quickly that flow rate drops. So how quickly is that membrane going to be clogging up on there? And there's different ways you can interpret the SDI value, but this is something important if you are fouling up membranes. Those are expensive. We don't want to foul them up. So if we're able to see how much sediment or this silt density index is in there, we can help prevent some of those fouling, especially when the property owner will take that restrictor on the drain line and say, oh, we're running all this water to drain. I'm going to tighten this down so I push more to the product side. Well, water's cheap. Those membranes are expensive whenever you foul them up. And this is going to be the main thing that will foul those up whenever you restrict the drain line flow. Pre-treatment essentials are very similar to our residential RO. Filtration, of course, that's going to reduce that silt and those colloidals. Dechlorination, all of our membranes nowadays are TFC, so they will essentially burn with any oxidants in there. Water softening or anti-scalant dosing, depending on the size of the system and what your hardness is, will dictate, should we go with a water softener or should we go with anti-scalant on there? Anti-scalant is just a chemical that we'll add before the membrane that just sequesters the iron and allows it to pass through to the drain side without fouling up and scaling on that membrane. So they each have goods and bads. The water softener, though, if you're looking at a large commercial application, that's a lot of water that you're putting through there. That's going to be a really high amount of salt, operational costs, and maintenance on it. Excuse me. So really consider the cost versus benefit of having an actual water softener versus dosing some type of anti-scalant in there. Usually on large applications. Go ahead.
What is the, how will you determine how can you offer an anti-scalar instead of a softener? Is there a number range of hardness that you recommend?
What would you say, Dad, on that one?
Not really. There's not a hard number. It's going to depend on, I mean, a water softener may be the way to go, but there are certain times when you just can't put a big enough softener on a system, and anti-scalant may be about the only way to go. But when you talk to your supplier, they can do the RO manufacturers a lot of times will use a computer program like ROSA or something like that that you can plug in all the parameters, and they can tell you whether anti-scalant's the way to go or not. And if it is, they can tell you how to dose it. They'll tell you how to dilute the product. If you're going to dilute it, they can tell you how much to dose. They can make sure that you don't put too much in there and plug things up. But like to Stephanie's point, test, test, test. And the main thing is kind of take a look at, when you're talking about commercial RO, you're talking about a pretty good investment. Talk to the customer and make sure of what the application is, what their requirements are, and how are they going to decide whether this thing is actually giving them the quality water that they need or not. What's their go, no go point At what point are they going to say this thing's not working? Or at what point are they going to say that, yeah, this is giving me the quality I want? You've got to know these things going in so that you can come up with the proper size system and the properly designed system.
The answer almost always is it depends with that type of thing. Hopefully that helped you out.
Stephanie, there's also another question in the chat. I don't know if you can see that or you want me to read it to you and Bill.
Go ahead, read it.
All right. In homes with greater than 30 hardness, with 4 in home, for POE RO, would changing membrane annually be option instead of softener?
Yeah, there's a lot of times that people, whether it's a home RO or a commercial RO, I've seen guys that sometimes I've seen people that sometimes will it's easier or cheaper for them to replace membranes than it is to put in pre-treatment. It's again it's a judgment call on their side on what they want to do. It's hard to say whether a membrane's going to last a year or so, but if you're in that if you've got that high hardness and you're using that RO a lot, like you should be, you may have to change that membrane once a year. It may be part of your annual maintenance. Fortunately, on point of use ROs, those things are the membranes are fairly inexpensive, not that big a deal. Commercial ROs, a whole different ballgame.
And fortunately, it's not going to be a complete failure with scale buildup on there. It's just going to be an increase in your pressure having to go in and decrease permeate coming through. So it's just slowly going to scale up from the backside forward. We can also, whenever we're dealing with multiple membranes, we can put them in different configurations to hit those different quality goals or applications for our customers. Usually single pass is going to be our standard application. That's no recirculation, usually a single membrane. And that's efficient for a lot of water coming through in an easy way. So we're not getting our highest quality of water. We are not the most efficient with it. We don't have a huge high recovery, but this is the easy forward way. We have double pass, which is where we can put them in a row and we can get that higher reduction of our contaminants and our TDS on there. We can arrange them either in parallel or series. Parallel is where we're going to have a couple of our membranes stacked and water comes in to all of them through the permeate, comes out through the permeate, and it all goes to the storage tank. It's not going to go from one into the other. Versus a series is where you're going to take the permeate from one and put it back into as the feed to the next. It's like what we do with desalination. Taking ocean water all the way down to drinking water quality, you have multiple membranes in a row. Each one is bringing down the TDS 90%. So first you have 90%, now you have 99%, now 99.9%. So they work in series to get you higher water quality at the end. You can also capture the concentrate flow or the drain flow and circulate that back up into a membrane so that you get higher recoveries. So it depends on what your goal is on here. If you're a homeowner and it doesn't have to be critical application, ultra high purity, and you're wanting to save on the amount of water that you're putting to drain, you can get those higher recovery rates by recapturing the drain and circulating that back through the membrane. If we're trying to get really high quality water for a critical application for a customer, that's where we'll focus on the TDS reduction and having multiple of those in series. For like example, a boiler feed, you have to have really high quality water. Might need 90% rejection, but the recovery is going to be a lot lower. So here's an example of a type of system. Pretty complicated, crazy one. We have our raw water coming in. We're going to have our feed pump here. Some pre-chlorination, depending on where this water is coming from. If it's municipal, don't need to pre-chlorinate it. If it's coming from a well, I strongly suggest it. Filter it, green tin filter, carbon filter, yep, softener and brine tank, or anti-scalant, but this is all your pre-treatment. Just like we do with any system, you have to select the right technologies, put them in the right order, and that's where your supplier can help you to choose that treatment train. And we're going to go into our RO system. You're going to have a reject drain, and the product, this is one of the applications that I am a fan of UV for. There's a lot of times where I'm hesitant to suggest UV, but this is a really good application for UV, is for this product water storage. Stagnant water grows stuff, so we want to keep that water moving, especially with large tanks like this. So you can recirculate this water in here, and adding a UV light on that recirculation is an excellent, excellent way to keep that water safe and not grow things in it. You can also adjust the water chemistry afterwards. We have nice, clean water. We can turn it into whatever we want. One of the most difficult customers I've seen is actually Starbucks. So if you have a large coffee shop, there is a very specific water chemistry that makes the perfect cup of coffee. And they want it consistent between all of their stores so that you experience the same taste no matter where you are. So they'll take it down to RO quality, and then they'll add in the exact mineral composition that they want for their coffee.
Hey, Stephanie.
Yes.
It was being asked, David had asked, wouldn't it be better to add the chlorine to the storage tank earlier in the chain?
That would be smart on that one. Yeah, I'd probably want it up here so that it has that contact time with it.
Are you talking about the raw water storage tank or the product water storage tank? The question.
David's going to have to answer that.
Yep.
I think he meant the raw water.
The raw water? Yeah, I mean, if you could put it into the storage tank right off the bat, you've got plenty of contact time there. And you're not sitting there with a stagnant water of unknown quality. So yeah, that would be an excellent time to introduce the chlorine to the system.
I have a question about the UV.
Yes.
Wouldn't it be better to have the UV after the product water storage tank?
I would have it recirculating on the product water storage tank.
Failing that, you're right, after the storage tank, not before. This drawing is a little that
It's crazy.
Yeah.
It's not my drawing, by the way, but it gives you an example of how complicated it can get. So we mentioned most of these. Whenever we're looking sizing, how large of a system do we need? First, we need to assess the water demand. How much water do we need? How quick do we need it? It's like, we need 20,000 gallons, but we need it all within these 4 hours. That's a big difference in between just being able to produce it slowly all day long and you're using it. You have to have storage for all of that at one point. So what's our average flow? What's our peak flow? how long do we need that water? Is there specific business hours? And what's our flow? We also make sure that the system fits in the space that we have. Some of these get really big. Make sure it fits through the door, because that's not fun when you get there. And with any system, any mineral tank too, measure the door and make sure you can get through. And plan for the future. A lot of these commercial applications as businesses are going to grow or change. So having these in kind of this module configuration with our pre-treatment and post-treatment is really nice, because we can scale it up as we need. Some of our instrumentation on here, I believe it'll change depending on which system or model you have. But in general, we're going to have a pressure gauge. This one has quite a few, but on the feed and on the permeate side, we'll have that pressure gauge. We will have flow meters, again, in and out of there. And this is where they can tighten down that drain line flow and make your life miserable. Take that knob off on some of those commercial applications so they don't muck with it. And then TDS conductivity monitoring. That's, in my opinion, one of the more important ones, especially for a critical application. I've used these commercial ROs as pre-treatment for an EDI system at Texas State before, and that's a critical application that you have to have high quality water to go into the EDI system. So it had a conductivity monitor on the permeate side, and if it went up above a threshold, the whole thing would shut down. And it was the RO had to produce high enough quality for the next step. So it was the pre-treatment. Maintenance, just like our residential ones, maintain it. That's going to be regular. Whenever you try to push that really far is when you can get burnt by it. When we're talking about the whole home with scale, that's not too much of a critical thing. But if we're looking at a commercial application for a distillery and we have chlorine hit through the activated carbon onto that membrane and it burns through it, then we have a larger issue. So make sure we do regular cleaning or replacement. We want to maintain these. So fouling or scaling, follow your supplier's guidance on that. Monitor any pressure drops, any conductivity bleed or bumps in that, and flow tracking. So we're having to push more and more against it. There's more of a pressure drop through the system, but we're getting less and less permeate flow through it. That's going to indicate there's something wrong in there. Keep everything in stock on hand ready, especially if you have any kind of chemical feed. So the anti-scale or anything like that. Sure, you have filters, chemicals, extra O-rings. Keep your stock ready and on hand. Also, anytime I'm working with RO, I personally like to have the gloves and everything packaged and covered, even with working with residential, because this is usually our drinking water or really high importance water, and you want to give the customer that peace of mind that you're really taking care of it.
Stephanie, if you could go back one slide. Frank had a question, and I have a feeling maybe Stuart is on this and he could answer. Frank is asking, that's a series RO style, right? Stuart, are you on the call, or Bill,
I'm
can
on.
you answer that?
I'm on, but I can't see, Sue. I'm driving.
Ah, shoot, I'm sorry. I put you on the spot there.
That,
Didn't mean
that
to do
one's
that.
that one's hard to tell. Generally, you can tell by the pump. Take a look at the pump where it feeds. Does it feed just one RO, excuse me, does it feed just one membrane, or is it split and feeding two membranes or more at the same time? Um, if so, that would be a parallel type system. Series type systems where you've got one where the pump is feeding one membrane, and that membrane, the concentrate from one, is feeding the next membrane in line, as if you had several of them in one membrane housing. A lot of times you don't have the space, and that would be the way to go through. So in that system, it's hard to tell right off the bat, but it may be a combination of the two. It may be that we're feeding two membranes off of the pump in parallel and taking the concentrate from those two and feeding the third membrane in line. So it would be a kind of a combination. Some of the things to keep in mind, especially when we're talking about performance on these things, is Stephanie touched base on SDI. Take a look at your spec sheet on the membrane itself, and it'll tell you down at the bottom that the performance is based on water temperature of 77 degrees, TDS of X amount, maybe 250 parts of it, sodium chloride. It may be 500 parts. It'll tell you what an SDI of less than 5 or an SDI of less than 3. You've got to do this stuff up front to make sure. SDI is the plugging factor. If you try to push too much water through that, trying to keep more water on your permeate side and less going to the drain, you're going to tend to plug those membranes up a little quicker. One thing that I would keep in mind on a commercial RO would be to have a log there. Somebody, especially if it's a plant, somebody is going to be walking around checking these things. If you have a log sheet that you every day or every week or whatever the period time is, you log on this thing. What's my feed water pressure? What's my pump pressure? What's my permeate? What's my concentrate? What's my TDS? And you log all this stuff, you can come up with a trend, and you can kind of see, is my quality going down, or am I maintaining everything the way I should? This is necessary for performance, to make sure that it's performing the way. It's also very necessary for any kind of warranty requirement. Some people think that, gee, these membranes crapped out quicker than I thought they should. Apparently, I've got a bad membrane and I want warranty on it. Just speaking from experience, if you go back to the membrane manufacturer and say, I think this should be a warranty thing, you need to show them some. They're going to ask right off the bat, did this thing work when you first put it in? If so, it's not a membrane problem. It's something, and if it's quit working, it's probably something that's operator error. Somebody crapped out that membrane. If you've got data that you can show them that says, no, look, I've got this, and this, now you've got a better chance of getting warranty on those membranes. Just something that I've run into in the past, and something that can help keep you out of trouble, maybe. Temperature is a huge problem. Not problem, but it's a huge consideration. A lot of folks will put these things in maybe in the summertime. In the wintertime, it's not producing as much water. Like Stephanie said, these things are geared for or normalized at 77 degree Fahrenheit water. Every degree that you go down from 77, you lose approximately anywhere between 1.5% to 3% of your production. So if you drop from 77 degree water down to about 55 degree water or so, you're going to have half the production that you were expecting. Sometimes in the car wash industry, we used to use a tempering valve where we would take hot water and cold water, just like in your bathtub tap at home, and kind of temper it down to get the temperature that you wanted. And we could keep it at 77, and we'd get better quality, better production out of the system. Inversely, every degree you go up from 77, you increase the production of the membrane from 1.5% to 3% or so. So the warmer the water, the more water you're going to produce. That's going to work for you and against you. First of all, you don't want to get it too hot. You exceed the specification on the membrane. Second of all, you might make better water. The quality probably won't be as good. You've got more quantity, just the quality may or may not be what you want. These are just a couple of considerations. SDI, temperature. Next thing to think about is where did the water come from? If you're operating on surface water, if you're like, for instance, North Texas, all our water comes from Lake Ray Wiley Hubbard over here. Surface water has got a lot of organics in it. It's got a lot of suspended solids in it. It's got a lot of other things in it. So therefore, your flux rate is how you measure how much water that membrane should be producing. It's measured in GFD, gallons per square foot of membrane surface per day. A normal 4x40 membrane would have somewhere around 80 square feet of membrane surface in it. Different manufacturers would have different numbers. Sometimes they'll tell you what those numbers are, sometimes they won't. But generally, a 4x40 membrane, you're going to be somewhere in the 80 square foot range. So if you're looking at putting it on surface water, you're going to keep that flow rate down to somewhere between 10 to 18 gallons per square foot per day, just because of the plugging factor. If you're on groundwater, you can flow it a lot quicker, a lot faster, somewhere, 15 to 25 gallons per square foot per day. Therefore, my rule of thumb, and this is just strictly Bill's rule of thumb, on a 4x40 membrane would be figure 1 gallon per minute on your permeate flow on that thing. And that's just for sizing purposes. That's get you in the ballpark. Obviously, once you plug in with your specific parameters and what your requirements are, you can dial that in. You may be able to get more, but just rule of thumb right off the bat, 1 gallon per minute per 4x40 membrane is just my rule of thumb. These are just some of the things to keep in mind when you're sizing these, and especially when you're troubleshooting them. When the customer calls and says, I'm not getting what I think I should, these are some of the things to look at.
Thank you. So yeah, looking at watching the maintenance and monitoring these systems, what should we look at in our troubleshooting or diagnostics if we experience a specific symptom? So let's say we're getting a flow decline through the system. They've noted there's less and less water coming through. Couple things could have happened here. Membrane fouling. So that's where we got the sediment through, or any kind of colloidals that are just gunking up and filling in on that membrane and reduces its surface area. Could be scale. So as the hard water comes in, it's going to be concentrated across the surface of that membrane. So if it comes in at 30 grains per gallon, by the time it hits the backside of that membrane, it could be at 50, 60, 70 grains per gallon. So it'll start scaling up at the far end and grow forward. You'll get a rapid decline. Your concentrate delta pressure will go up. So make sure that your anti-scalant's there. Make sure the softener's not bypassed or turned off or out of salt or something silly like that. If you have an element compaction where it's physically distorted, make sure that you stabilize the system. Make sure that whenever you feed water into it at installation, just like our mineral tanks, we don't want to bust it open and that water comes through and hits one of the components at a higher flow or water pressure than it's going to normally operate at. We don't want to bang it right off the bat. Or feed channel blockage, so it's not getting as much water coming in, but our flow meter should be able to isolate that. What if we're getting TDS creep coming through? So we're not getting the quality that we want, but we're still getting enough. Check the O-ring and that brine seal. On these membranes, there's a direction that you put it in. Look at the flow arrows, put it in the right direction. If not, there's not going to be that brine seal around the permeate side, the far side, and you'll get a mix coming through of concentrate bleeding into the permeate line. We oxidize it. Any chlorine, chloramines, any other oxidant, ozone, hydrogen peroxide, are going to permanently, irreversibly damage the membranes. That's when our carbon beforehand has exhausted, allows it to come through, and it will hurt that membrane. I have, though, to save on costs on a membrane that got a bacterial growth on it. Chlorine's really quick to oxidize those membranes. Hydrogen peroxide's a little bit slower on damaging the membranes, so we were able to disinfect the surface of that membrane by soaking it in hydrogen peroxide, then clearing it off. Yeah, it did take a hit off of the life of that membrane, but we were able to salvage it that way. So hydrogen peroxide, just note, is a little bit better in that kind of situation. Hydraulic shock, back pressure, again, slow open valve control. And then here's that high feed temperature. As you go up in temperature, you are going to get more water through, but it is going to be lower quality. Essentially, it's going to relax that membrane. There's not as much of a energy difference in our osmosis action. So it can allow more TDS to come through. And come nothing else and you can't figure out what's going on, do a post-mortem. Take that membrane, cut it open, see what it's doing in there. That will help you identify what was the problem at the beginning. So what do I need to do to fix this fouling on the membrane? If you see it's obviously orange-brown and you're on a well that you know has iron, well, we got iron onto the membrane and it's oxidized, we can see it. White crystalline scale, so it kind of turning into a rock. That's going to be your hardness breaking through. So make sure you have either the water softener or the anti-scalant to help protect it. Bioslime, that's where you have microbes come. It's dark, it's warm, it's moist, it has a perfect pH and nutrients for it. Bacteria loves to grow in RO membranes. Brittle or cracked, that's what it looks like whenever it gets oxidized by chlorine. It's like it burns it and it gets really crunchy. Then telescoping or crushed, that's where you've hit it with water pressure, water hammer, something physical, and it's crushed in those membranes. Edge discoloration, so you're noticing it right around here. That's where, check out that O-ring brine seal on there. Excuse me. You're probably also going to get TDS creep with that, but you'll notice that there's more of a ring on that side. And then gel colloidals, very similar to the iron. It's where you need to up your filtration, get that SDI down so that you're not, or increase your drain flow so that you're not gunking up that membrane as quickly. But barring nothing else, post-mortem.
How far away would you have to run an ozone if you wanted to run ozone before the RO?
Depends. What's the demand on it? How much flow? You had a rule of thumb on how quickly that went down the other day, I thought, Dad.
I don't remember how fast, but using ozone is an excellent way of disinfecting. you've got to monitor it. It's got to be very precise. You don't want to overdose it. You don't want to underdose it. So again, with commercial RO, you're going to have somebody there pretty much tweaking this system. It's not something that you can put in and walk away from. If you think you're going to put in a commercial system and wash your hands of it and say, okay, I'm done, probably not realistic. Somebody's going to have to monitor that thing. Somebody's going to have to tweak it. Somebody's going to have to keep an eye on things. And an ozone injection system would certainly be one of those.
What I don't even know what I was going to say. I'll come back.
Okay.
Yeah, as a recap, know your water. What are you starting with? What's the water source? Full water analysis. Design smart. What are you trying to get to? What are the customer's needs? What is the area logistics? So design it smart so that it meets your application and demand so that your customer's happy. Like we were just talking about, stay proactive. You are involved with this. You are married to it. And then test the system for efficiency. First off, prove to the customer that you did the job you said you were going to do so that they don't come back later on and say, well, never actually did it. CYA, prove it. And then don't rely on assumptions. You always want to monitor it. Again, stay proactive.
I remember my question.
Go ahead.
How would we know if ozone is ruining the membrane?
It'll have that same brittle kind of effect on it when it oxidizes. Probably also, once you've ruined it, you'll get the TDS creep, just like hitting it with chlorine.
Any kind of oxidant is going to basically it burns a hole in the membrane, and you're going to get it's going to be making a lot more water. So if you notice that your flow rate's going up, but your quality is going down, at that point, I'd take a look and see if you're not, and check and see what your oxidation level is going into the thing. On a point of use membrane, it's not that critical. If y'all ever get a membrane that you're having the same problem over and over again, and you're having to replace membranes, to Stephanie's point, autopsy one of those things. It's pretty cool that you can cut it open and you can fan the layers out and see what's in there. And you can kind of get an idea of how these things are built, in addition to seeing what does it look like if you've got the crystalline substance in there. Obviously your softener is it's not probably not working like you think it is. If you've got different coloration, it'll give you some answers to go back and look. It's after the fact, but if you're it may keep you from having to keep buying membranes over and over and over again and keeping the same problem going.
Just like having a mineral tank that's imploded. It's like, you had a pressure vacuum on it at some point. No, I didn't. Looking at this symptom, this result on it, you had this issue. I guarantee it. So we look at it after the failure, but we were able to identify what was the cause and hopefully correct that. Any other questions, comments, concerns?
I know we threw a lot of information at you, and commercial RO is one of those things to where it's so site specific, and it is so it depends on what the needs are of the folks that were requesting the system. And it's something you just got to do a little more homework, but we sell a lot of commercial RO systems. They operate very well. They do a great job. You've just got to do your homework and make sure that you apply it correctly. That's all. But it can be a great addition to your business.
There were a couple questions. Sorry, I was muted earlier. I'm just talking away. So Frank is asking if we have a formula sheet for sizing. Do any of my charger guys know if we have a formula sheet for sizing these commercial ROs?
You mentioned that program
That's-
earlier.
That's when you say a formula sheet, I mean, you've got to work out what your demand is, how quickly you're going to produce it, and how much storage you've got in place. So I've got something together for that, but maybe we could get that available, say, within about a week, Sue, and put it out there.
Love it. You bet. You bet. And I have all of your emails
Great.
that are on this, so I'll be sure that
But
you
there's
all are included.
okay. But there's a lot to consider, because as Bill and Stephanie said, one key. Okay, what is your incoming temperature? It's going to vary throughout the time. Unless you're on a well, it's going to be fairly stable. And typically in Texas, well water runs about 60 degrees. Okay, so 60 degrees, you're going to produce 75%, 70 to 75% of the rated value of the RO. Play when we do an electronic profile. So one thing that we can do, and it's on the Charger website, is that water test that we offer. I think it's about $275. If you do the most advanced one, that has everything that you need to do an electronic profile of an RO. And if you take that up with your customer, you do that test, then we can determine how much you're going to produce, what the pre-treatment's going to be, what the most efficient way of doing things is, and provide you a great solution to your customer. It's pretty accurate if you follow the rules. I do a lot of, whole house RO systems, as well as other applications for RO. But RO is your friend if you do your homework on the front end. If you mind, as
Thank you, Stuart. You're breaking up a little bit, but yeah, you can always call your Charger branch and they can help you through it. And when Stuart's talking about the website and where you can find things, on our homepage, up at the very top, there's a link called For Professionals. And if you click on that, you'll find all sorts of assets that'll be really helpful for all of you. And if there's anything that's missing, give your branch a call and say, hey, do you have this? And more than likely we do, and I can post it there. So also there was a question about these sessions being recorded for playback. And I have put our YouTube channel in the chat where you can find these videos. I'll be uploading them and much, much more. And then there was one more, oh, the link isn't working. Isn't that interesting? Huh. Okay. Let me double check. That's what it's saying it is. So I'm going to have, let's see, Patrick, you had a really long question. Maybe you could explain it with your voice. That would be super helpful than having me translate.
Can you hear me?
Yes.
Okay, so my understanding is that membranes reject about 96% of arsenic 5 and about 50% of arsenic 3. So if somebody has arsenic in their water and they want to install a whole house RO, and you want to install a MetSorb system, it's kind of like a stopgap against arsenic breakthrough. Where would that be installed in the line? Would it be installed as pre-treatment or post-treatment? And then would installing it in between the whole house RO and then the storage tank be beneficial? That way you'd be taking advantage, not only the low pH, but the low gallons per minute flow rate. And then just place the MetSorb tank preventatively.
You could do it either way. I keep falling back to the same old adage about going through different steps, clean up the water, get out the big stuff, then refine it as you go through. So therefore, going on that, the RO would be the last thing in line. However, you're in this situation, I think that MetSorb system would probably be better to put on the tail end as just capturing what didn't come through. Something to keep in mind with arsenic, that's a health claim. Somebody's going to have to monitor that on a regular basis to make sure that it's really working. And as long as you're doing your due diligence, it should, you're good.
I appreciate stacking the Metsorb on that, because even with 96% rejection, that 4% that comes through could potentially still be a dangerous amount. That redundancy is excellent. Any other questions?
Did I miss anyone's? Please speak up if I did.
Looked like David Davies had one. As a quick ballpark, would it be reasonable to say size of RO is at least twice the daily consumption and the tank to daily consumption, but it can vary. So I guess that's the question.
I like having a storage system that would hold a day's usage or a specific time frame usage. The bigger the storage tank, the smaller RO you have to have, and vice versa. But I think on a critical application, having a full day's use of water available would be a prudent thing to do. So yeah, I agree.
Keep in mind that ROs work better when they work. We want to keep it running. We want to keep that water moving through it. We want to keep the RO working, and it really helps it out. So we don't want it to produce too quickly and then just sit there for a long time. Any other questions? Last chance. Thank y'all so much for your time and my contact information. If y'all have any questions, comments, concerns, please let me know.
Yes,
Thank
or
you.
feel free to
Thank you so
call your
much,
local.
Stephanie.
Yes, thank you all. Thanks for joining and thanks for your business as always. Have a great
Thank
Friday
you.
and a
Guys, have a
wonderful
great day.
weekend.
Thank
All
you.
right. Thanks,
too.
everyone.
Thank you guys for the training. We appreciate it.
Absolutely.